class, we're about to start lesson 9, permutations. It says on the mathematical reasoning test, you may be asked how many possible permutations or sequences are possible given a group of items. Considering the following example. Eliza is planning her day off. She wants to visit the art museum, try the new coffee shop, call her mom, and take a walk, but not necessarily in that order. How many possible sequences of these 4 activities are there? The question asks you for all possible permutations or ways to sequence the items. Thus, coffee, art, mom, walk, and art, coffee, mom, walk are 2 different possible outcomes. Consider how this problem differs from the combinations problems on pages 300 to 303. In those cases, order did not matter. In a permutation problem, order does matter. Define how many ways you can sequence all the items in a list. Multiply the possibilities like this. Start with how many things could go first. Here there are 4 possibilities for Eliza's first activity. Once she has done that first activity, 3 possibilities remain. After she has done a first and second activity, 2 possibilities remain, and then only 1. So you simply multiply 4 times 3 times 2 times 1. There are 24 possible permutations. Some permutations questions may ask you to determine the possible orderings for only some of the items in a list. Consider this example. Example 2. 10 runners are competing in a race. There are prizes for first, second, and third place. How many possible sequences of the top 3 prize winners are there? Notice that you are not simply figuring out how many groups of 3 can be made out of the 10. Rather, you are figuring out how many sequences of 3 can be made out of the 10. That can sometimes be represented on the GE test with the notation P10 of 3. So, now multiplying 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 will give you all the possible permutations of all 10 runners. So that approach will not work here. Instead, start with how many people could win first place. Here, 10. Second place. Once someone has won first, there are 9 possibilities for second place. Once someone has won first and someone else has won second, there are 8 possibilities for third place. And then you stop multiplying. So 10 times 9 times 8 is 720. There are 720 possible ways that the runners could be arranged in the top 3 prize winning slots. Note that simply multiplying 10 by 3 would not work. Now, we come here, it says read the problem and decide whether you are being asked to find combinations or permutations, then solve. Okay, number 1. Naomi is trying to remember the password for her email. She knows that it has the following characters in it, $L7, but she can't remember the order they go in. How many possible sequences of these 5 characters are there? Okay, so basically, this is a permutation because order does matter. So, what we would do is this here. So, with number 1, it says, so we have 5 possible combinations here. So, the first item she could pick is out of 5. So, once she picked the 1 here, the second would be 4. The third would be 3. The second to last or the fourth would be 2. And then until you get to 1. So we will multiply all of these. So 5 times 4 times 3. 5 times 4 is 20 times 3 is 60. Times 2 is 120 times 1 is 120. So that would be your answer for number 1. Now, number 2, we say, it says Bilal is going to the museum. She wants to see the contemporary art exhibit, the Impressionists, the Greek vases, and a special Picasso exhibit, but not necessarily in that order. How many sequences of those exhibits are possible? So basically, with number 2, we're looking at how many of those sequences are possible. So she has 4 different possibilities. So first of all, she could choose between 4 for the first possibility, 3 for the second, 2 for the third, and 1 for the last. So we will multiply all of these values together. 4 times 3 is 12, times 2 is 24, times 1 is 24. Okay, now number 3. 5 students in a class have volunteered for a special project. Only 3 can actually help with the project. How many groupings of 3 out of the 5 are possible? So basically here, we're doing the 3 out of the 5. So this is a combination problem, and we're going to go back to what we did on the second lesson for 8. This dealt with the superhero powers. Remember, it was 3 out of 5, which is the same thing for number 3. We have 5 students and only 3 can actually help. So this will give us 10. These are all the combinations of the students, and that will only be 10. So our answer for number 3 would be 10. Now, if you want to write down all of these combinations, you can. And you can start off by saying this is what you started with, and these are the combination of 3 students being able to do the specific task. Okay, so with that being said, number 3 is actually 10. Your answer for number 3 is 10. Okay, number 4. It says Tyrell is the curator at a gallery and is deciding how to arrange 6 paintings that will be displayed in a line along one wall. All 6 paintings will be included. How many possible sequences could Tyrell choose? Okay, so with that being said, and this is problem number 4, there are 6 possible paintings. 6 paintings. 1, 2, 3, 4, 5, 6. So 6 will be the first. 5 possibilities for the second. 4 for the third. 3 for the fourth. 2 for the fifth. And 1 for the last. Now all this is multiplication. We'll multiply all of these values. Now what I want to do, I'm going to use the calculator. So with that, we would take 6 times 5 times 4 times 3 times 2, then times 1. And that gives us 720. So the answer for number 4 is actually 720. So I'm going to write the answer down here because I ran out of space. So it's 720. So this is the answer to this here. It's 720. Okay, now we move on to problem number 5. Problem number 5, it says choose the one best answer to each question about combinations or permutations. You may use your calculator. Okay, so with that being said, Soraya has been given 6 tasks to do at work, but she has time to complete only 4 of them. She must decide in what order to do the task. How many possible orderings of 4 tasks are available to Soraya? So this is problem number 5, and it is 4 tasks. It is 4 that she could do. But remember, it's 6 tasks that could be done. So the first would be 6, the second would be 5, the third would be 4, and the fourth would be 3. So we will multiply all these together. 6 times 5 is 30, times 4 is 120, times 3 is 360. Now we can put that in a calculator. I don't know, sometimes this computer be acting up. But let's move that over here. Okay, so we'll multiply that. And if you notice here, we could just multiply 6 times 5 times 4 times 3. And that gives us 360. So number 5 is 360. All right. So now we go to problem number 6. Problem 6, it says in a certain public garden, the gardener wanted to show the different visual effects that arranging flowers in different sequences can have. So he chose 3 kinds of flowers and planted flower beds showing each of the possible sequences of the 3 kinds. How many such flower beds did the gardener plant? Okay. So with that being said, but hold on, before we do number 6, I forgot that we were supposed to put down C also. So 360 was C. So with number 6, there are 3 different types of flower beds. And we want to do that, we want to show the different sequences. So the first would be 3, the second would be 2, and the last would be 1. 3 times 2 times 1 is 6. And then for 6, it would be B. So that would be the answer for number 6. Okay, now, for number 7, it says 10 people hope to become extras in a movie. The movie's cast and director would choose 4 people to fill the following specific roles in the movie: bystander 1, bystander 2, bystander 3, and bystander 4. How many ways could these 4 roles be filled? Okay, so let's look at it. So it's 10 people, and there's only 4 rows. So we would do 4, and then 10, the first would be 10, the second would be 9, the third would be 8, and the fourth would be 7. So we'll multiply all of those values. So we got 10 times 9 times 8 times 7. So now we will go to the calculator. So we multiply this out. 10 times 9 times 8 times 7. And that gives us 5,040. So that equals 5,040. And 5,040 is D. All right, now we go up here to problem number 8. It says questions 8 and 9 refer to the following information. Clark and his daughter are at the amusement park, and Clark is offering his daughter a choice. They don't have time to ride all 6 rides at the amusement park, but they can ride 3 of them. Okay, so how many combinations of 3 rides could Clark's daughter choose? So we would, okay class, this is a combination. Now it says how many combinations, just reread it again, how many combinations of 3 rides could Clark's daughter choose? Now if you look back at problem number 8 from the first part of lesson 8, they gave us the same scenario. You only was allowed to pick 3 of the 6. And these are all the combinations. You can name the rides LMNOPQ. And then you can write down all the combinations. There are 20 different combinations that you can have riding that ride. So your answer here would be B, utilizing these combinations here, and you could write this out. So your answer would be B, which would be problem number 8, which would be 20. So what I'm going to do, I'm going to change this to B, just in case you all forget that I had it as B. Okay, so your answer here would be B for problem number 8. And those are the 20 different combinations. Okay, now, number 9. It says here, Clark's daughter can also choose the order in which she wants to enjoy the rides. How many possible orderings of 3 out of the 6 rides are possible? Okay, so now, with that being said, you can pause this if you haven't finished copying down the combinations for number 8. But now, for number 9, For number 9, 3 rides, 6 possible orders. So you have 6 for the first, 5 for the second, 4 for the third. So now you multiply this out. 6 times 5 is 30, times 4 is 120. And 120 is C. So that is your final answer. And we are done with lesson 9. And now we'll put this up on YouTube. And you have a wonderful day.